Focal length of convex lens for red, yellow and violet rays are 100 cm, 98 cm, 96 cm. Means for red, focal length for red is 100 cm and focal length for yellow color, which is supposed to be the mean color, is 98 cm. Mean means average, and the focal length for the violet is 96 centimeter. Okay, so these are the three focal lengths for different colors for a convex lens. What is the dispersive power of the material of lens? So we have to find the dispersive. So first of all, let me quickly explain to you what is exactly the dispersive power. Actually, in case of thin prism, if you remember the formula of deviation, that in case of thin prism, the deviation produced is given by mu minus 1 into A, where mu is the refractive index of the medium of the prism and A is the angle of refraction. As we know that for different colors, we have got different values of mu. So delta for the violet is equal to mu for the violet minus 1 into A. Delta for the red color, it will be mu red minus 1 into A, and delta for the yellow color is mu yellow minus 1 into A. That is the case. So when in case of prism, a light ray is incident, then different color segments are separated. As we know that the highest bending is for the violet color and the lowest is for the red. So these colors are deviated by different angles depending on the values of their refractive index. Violet has got the maximum refractive index, so it has to suffer a maximum deviation for that. Okay, so there are several terms which are defined here. For example, the angle between the red and the violet color. Suppose we denote it with the phi, then here the value of the phi is equal to delta violet minus delta red. As we can see here, delta violet minus delta red is mu violet minus mu red into A. And delta for the yellow color is supposed to be the average deviation for all colors. So delta for the yellow color according to this is here mu yellow minus 1 into A. Ratio of these two, this particular thing phi is known as angular dispersion. Normally what happens, these topics are overlooked by students. That is why I am just trying to revise these concepts once. Okay, so phi is the angular dispersion, delta violet minus delta red. So mu violet minus mu red into A, and this is the mean deviation. Ratio of these two is known as the dispersive power, omega. So omega, the dispersive power, is equal to mu violet minus mu red divided by mu yellow minus 1. So this is the formula for the dispersive power of the material. Okay, and it is independent of the thing that it was prism or some other. It is just based, material based property. So we can use this for the lens or anywhere else also. So omega is the dispersive power of the material of the prism or any other material. And as far as focal length is concerned, we have this formula 1 upon f is equal to mu minus 1 into 1 upon r1 minus 1 upon r2. Since r1, r2 are going to remain same for all colors, but mu is going to change according to the color, as we know that mu depends on the wavelength of the frequency. So 1 upon f of yellow becomes mu yellow minus 1 into this bracket of 1 upon r1 minus 1 upon r2, and 1 upon f red is equal to mu red minus 1 into 1 upon r1 minus 1 upon r2, and similarly for 1 upon f violet it is mu violet minus 1 into 1 upon r1 minus 1 upon r2. So we have to find the value of the omega, and you can see it from here that we can arrange these expressions like this. Omega is what? Omega is mu violet minus mu red divided by mu yellow minus 1. So what we can do is this: 1 upon f violet minus 1 upon f red divided by 1 upon f yellow. Alright, so if you solve this, then what are you going to get? You are going to get this value, which is nothing but the dispersive power of the material of this lens. And you can calculate this value. You are going to surely get this answer A. So A will be the correct answer to this question.